Whoa.
So I guess like for me, like maybe the wording was sort of throwing me off. So the question's asking to find the longest palindrome that can be made out of like an input, right? And it's like, but for a palindrome, the length sort of stays the same, right? Like it's just the letters being shifted around. So I guess I was like trying to figure out, well, at least in some cases, right? So I'm trying to figure out, I guess, how to like determine, like I don't know, like messing around with the input and stuff because we have to determine whether or not that input is a palindrome first, right? We need to check to see if it is.
So, so no, this is a good clarifying question and one that, definitely don't wait to ask them. If you have clarifying questions, please write them in Slack, hit me
Yeah.
up in Zoom, right? That's the foundation of the question.
Yeah.
And if we look at the question here, I'll share my screen. Um, this is a different problem, but here, right? If we look at this question, it says, given a string which consists of lowercase or uppercase letters, find the length of the longest palindromes that can be built with those letters. So that doesn't mean we're using all the letters. It just means that's
Um,
what we can build. So
Out of those letters, right? Okay, cool.
you'll see that they're not using B here.
Right. Yeah. So it's just if we're giving like a long string full of like all of these letters, like what's the biggest palindrome we could make out of those letters, essentially.
That's right.
That makes a lot more sense.
Exactly.
'Cause I think I was when I was reading it, I was having a lot of trouble trying to figure out what it was trying to ask me, but I was still trying to like build a palindrome out of things because like, but I just wanted to make sure I was doing it the right way, if that makes any sense.
Yeah, that makes sense. What else? What else do people find tricky? Or what did they notice? What patterns? What really come on, we're not really anonymous. I know we're all online and stuff, but like in the classroom people would be talking. There's no wrong answers. It's how it was your experience with the problem.
I mean, for me, that was the part of it that made it, excuse me, made it a little difficult for me was trying to shift around the letters to see where these palindromes would be, and then finding that the length of what was actually a palindrome.
I see. So you were trying to so you were trying to make different palindromes from them and then see the length.
Yeah.
Okay? Yeah.
Wait, so Corey, so you know how like yesterday we did like the palindrome problem where we took the approach of like having like the counter object and things to determine whether or not like we saw that one odd letter, like
Yep.
that appeared. So if we did something like that, right? We found that we found where we found like that more than one like odd letter. We know that the rest of those letters can be made into palindromes. Like, would that be sort of like a good place to start? Because at least we would know that, okay, out of all of these letters, like we can use this bunch of letters to like make the palindrome. And then all we really need to do is calculate the length, I
That's
think.
right.
So
A
it's
hundred
like,
percent that
oh
that's
man.
that's like this problem is nearly identical to yesterday's problem.
Yeah.
I don't know if it I don't know what percentage of people realize that, but that's something we should always be looking for. It's like we just did a permutation of a palindrome problem. So we came up with all the rules of what makes something a palindrome yesterday and how we can uh,
Determine.
check to see if that is. So it's essentially the same problem, just with the little twist, which is now we have to figure out the length. But the same rules that we came up with yesterday all apply.
Yeah, it was just the wording. Like the wording is the one thing that sort of it just sort of like threw me off. But the approach now that like like I asked the question where it's like, all right, cool, like that's what I'm looking for. Then it's just like, okay, cool. Like speak the counter object, see where you could find that that odd letter. Then you know how many letters you actually have for the palindrome, and then just count the letters, and then that's how long you can make. That's how many letters you can make palindromes out of. So yeah.
Yeah. So let's kind of like plan this out a little bit. So everybody can see this, yeah? Yes?
Yeah.
No?
And it's case sensitive, right?
Right. So we don't have to worry about lowercasing anything or anything because it tells us that this is not a palindrome already. So let's start like thinking of our approach. So we could use a counter object, right? Create a counter or occurrence map. Sometimes people call it occurrence map of each character. Okay. I don't know why it turned into character data, but okay. So if we did that, right, we'd end up with something like, let's say we already know how to build a counter. We've done it every week for 2 months. So let's say we had something like this, and we had A, and A pointed to 1, and then we had B pointing to 1, C pointing to 4, and D pointing to 2. Okay, so let's pretend, oops, sorry, I'm trying to format this. Okay, so if this is our occurrences, what is the longest palindrome that we can make? Let's think about this. Maybe someone else can talk through it.
6. And the answer, wait, hold on, let me unmute myself.
7.
Okay, who said 7?
Me.
Is that Doug?
Yeah.
Okay.
I agree with 7.
7. I agree.
Okay, so of the few of you that are talking and saying 7, like, how are you coming to that conclusion?
Well, because you have a C that has 4 occurrences, and then you have D that has 2 occurrences. So you know those can go in. Then you know that a palindrome can only have 1 occurrence of an odd value. So you would have to add up the C plus the D, 4 plus 2, and then take one of either A or B, not both, and then
Okay.
it'll be 7.
One of A or B.
Yeah.
Okay, I'm with you. So what about if I were to make the change to the string or to the counter and I ended up with this? What would be our longest palindrome then?
Three.
It would still be 7.
Still be 7.
Yeah, so this would still be 7, right? And let's talk about why, right? We still have 2, which is our even now, and if we can only have 1 odd, right? But but we still want all the other numbers. So like we still have the number of evens here, which is 4. So we still have our 2 and our 4, and then and there's not 2 and there's not 2, so we can either include the C, the B, or the A, because those are the odd numbers left. So let's try again. Let's see if we can keep going. What if I make this a 3?
Wouldn't it also be like actually no, maybe
9.
Okay, Doug, you want to tell us how you get to 9?
like a 9, yeah.
Mod all the numbers, so A3 is gonna become 2. 5 is gonna become 4.
Wait. Oh, so you're not really modding.
Well, I'm finding like the
What's the math you're doing?
so I'm just trying to figure out like I guess the what's that word?
Well, I was writing value, but
Yeah, the value, I guess. Oh, it's not. Yeah,
What's the math formula that you're doing?
So I'm dividing it by 2.
You're dividing it by 2. That would be, this would be 1 then. This would be 0.
You could just
This would be,
subtract
this
it.
would
No,
be
I guess
2.
subtracting it.
Subtracting?
No.
What? What was the math? Because you actually you're doing very specific math. You got 2, 0, 4, and 2, right? Is that what
Yeah.
so how did you do that math? Maybe somebody can help too if they know.
I think maybe because you would have 9 because you can choose one of the letters to be the pivot letter. But if you, so you have your D, which is your 2. Then you have your C, which is your 5. Now you can do a remainder like of divided by 2 and get the remainder and determine like if it has an odd value, and if it does, that can be your pivot, or you move on to the next letter. And you would do the same thing for A. So the 2 would become, so the D would be 2, the C would be 4, and then the 3 would be I'm sorry, the A would be 3 if you keep C as 4. Or if you leave C as 5, C would remain 5, D would remain 2, but then you have to change one of these odd values to be an even value.
Like A to be
Yeah, like
2
right.
instead of 3.
Right.
So you can
Right, so
either
A is going to
have
be
A as 2 or C as 4.
Mm-hmm.
okay. So what about this idea, right? What about if we kept track if we have an odd, right? Because we only care if there's an odd because we're ignoring all the other odds, right?
Right.
And then how do we find the next highest even value? What's the formula? How do we, like, if we just wanted to go through it and have this line be a 2, this line be a 0, this line be a 4, and we would say, oh God, sorry. And we say this line is a 2. How would we, and then we could add these all up and we could say 2 plus 4 is 6 plus 2 is 8. And we know we've seen an odd because we have a little marker. Then we would just add the 1 for the odd and have 9. Do we get what I'm talking about?
Yeah.
Okay.
So you go through that object, right? And then you would just like check to see if it's even or not, right? And if it's not even, I guess you'll, but like, oh man, I'm
Oh,
Can we
Corey.
divide by 2 and then whatever number we get just times it by 2?
Wait, 3, 4.
Like
Yeah, that's let's see, would that work? So so you're saying value is equal to like math dot floor of value divided by 2 times 2. Is that your
Yeah.
equation?
yeah.
Okay, let's see. Does that work? So 3 divided by 2 we'll say is 1 times 2. Okay. 1 divided by 2 is 0 times 2 is 0. Nice. 5 divided by 2 is 2. And then we'll say times 2 is 4. 2 divided by 2 is 1 times 2 is 2. Yeah, I think that works, Doug. Can anybody think of an alternate formula?
I'm trying to think of one like where we could subtract 1, but I'm trying.
Yeah, I was on the same thought as Marvin, like subtracting 1 from the odd values, adding those values up, and then just adding an odd value at the end once we get the even values. So
I see. So,
yeah.
okay.
I guess
Yeah.
Let me see what that formula would look like.
Well, how do we
So
determine if something's odd?
modulo.
Okay, so we'll say value mod 2.
Value mod 2 equal, if, you know, if value mod 2 equal 1, then it's odd, right? Or
What is this? What will this give us? What are the possibilities?
1 or 0.
Can we do something with that?
if we get that 1, then we can add that to, math.
Do we want to add, Marvin? So if we get 7, what number do we want to get at the
Oh,
end?
we want to get 6, right?
Right.
So if value modulo 2 like equals 1, then we can minus 1 from that value.
Right. Or couldn't we just do something like that?
Yeah, actually, yeah, that makes actually a lot more sense, because that way we're taking away that 1 and we're keeping that value. So yeah.
Right, because if it's even, we'll just be
Yes, value minus that
Odd.
remainder.
we're
Okay.
subtracting 1.
It'll
Uh,
be 0 if it's even. So yeah.
So this should work, and Doug's formula also looks like that's going to work for us as well, which is cool. I hadn't thought of this one earlier, so that's exciting. Okay, so we say we create an occurrence map. We'll create. Let's like think about our variables. So what's a variable we need to be keeping track of?
Occurrence.
Yeah, that's
Like-
going to be
What do you mean by what's a
here.
Length.
length?
Like the total, yeah. The length.
So okay, length. I like that. Length variable. Love that. I see Deja wrote that too. The value next to index. Okay. Needed. Any other variables needed?
That first odd number.
Okay, so maybe a has odd. Because we can just determine whether or not there's an odd there. This may, or we could even say has odd. Well, we'll start with just variable. We'll decide, like this implies a Boolean, but we'll see if there's something better later. And then what's our next step that we're going to try to do? How's the actual logic work?
Loop through the object.
Okay, so we're going to loop through object. Yeah. And what are we going to do inside that loop?
Add the
Apply our logic.
Apply logic. Okay. What is?
Are we going to add to our length?
Okay. Add to length. Whatever this is. Anything else we need to be checking for? Oops.
Casings, or maybe trying to think.
Do we have to think about our variables? Do any of these variables help us? We're updating length.
That has we need to keep track of that. Like if we've already seen an odd, we don't want to see an odd again.
Well, it's
Or-
okay if we see it again, right? Because we'll just ignore that.
Yeah.
But you're right. We have to check if we have an odd, right? Because like, if we
If
have
there-
an odd, we have to add 1 at the end.
Yeah.
Do we agree with that?
Yeah, I agree.
Yeah.
No matter how many odds there are, we're only adding 1 at the very end.
Yeah.
Okay. So, update has odd. Great. And then Any other steps we got to do for this function to be complete?
We need to return the length, right?
Yeah, return length. Just by itself or with anything?
I think the output had like a string or something associated with it.
No, I don't. I think it's just a number.
Oh,
Yeah. But let's walk through our example here. If this was our numbers, we'd have 2 plus 0 plus 4, 6, 2 is 8. So right now our length is 8, but we know our answer should be 9. So we can't just return length.
can you say that one more time? Sorry, I couldn't hear you for the last part.
Well, if this was our counter object, and we've done this so far, right now we have has odd being like true or 1 depending. And right now our length is 8. But the answer should be 9.
We need to add that 1 at the end.
Right, okay. Turn length plus has odd 0 or 1, right? So any questions on our approach here? All right, so let's code it out. Let's just follow our steps. So do I need to recreate our counter helper,
Yes.
or do we remember it? Okay, well, I'll just do it again. So counter string, right? So this is just a string, takes in a string, it's gonna have an object. I'll call it counts. We're gonna iterate through our string for let character of string. We don't care about indices, we just care about the individual characters. We're gonna check if counts as a character. If it does, we'll increment it by 1. Oops. I lost where I was. By 1, otherwise it will be counts at character. And we'll just assign it to 1. At the end, we'll return our counts. Right? So this is hopefully a helper method that you feel comfortable writing. If you don't yet, write it, just keep writing it until you do. Okay, so we've got this, and we'll have our counts. Counts is equal to counter string of string. So that's our step 1. Step 2 is length variable needed. So let's go ahead and add that. So we'll say let, right? This is let because it's going to be something that we're going to be changing throughout. Let length. What should it initialize as?
0.
Sounds good. We'll say let has odd. So what's a good variable for this to be?
Boolean.
Boolean.
Okay, we can start with Boolean. So should we start it as what? True or false?
False. We haven't seen an odd yet.
I like that, right? We have not seen an odd yet. Therefore, we should be starting as false.
Can you also do
Okay.
it as like a 1 or 0 or 1?
That too.
Can we do it as a 0 or 1? Oh, I like that even more. I love where we don't have to use logic, right? Because like we could be doing like if modulo 2 is equal to 1, value is equal to this, otherwise value is equal to this or that. But having something that's like explicit is always nice. So if it's 0 or 1, then we can just return this length plus has odd instead of saying if has odd, return length plus 1, else return length. This way we can just have one statement. So, okay, what should it initialize as?
0.
0.
0. Right, excellent, because we have not seen the odd. Okay. So we've got our variables loop through object. Well, that means that's a for in loop for let character in counts. Okay. And then we have some value. So let's do our math. So loop through object, add length to this. So we'll say, let's go ahead and do our equation. We say length plus equals, and we said it's going to be math.floor of the value, so counts at character, divide by 2 times 2. Sounds good to me. And then it says we will update has odd. Okay, so if counts at character modulo 2 is equal to 1, then has odd should become what?
1.
1.
Right. So if our counts at character mod 2 is equal to 1, has odd equals 1. Sounds good. And then at the very end, we're just returning our length plus our has odd. Return length plus has odd. And let's try this out in Leetcode. So let's copy this. We'll move over to our Leetcode and we'll run our code. First, we'll just run it to see if we have any like egregious errors. Okay, 7.7. Let's go ahead and submit it. And we got it. It passes all of our tests. Pretty cool. Any questions on the way this one is solved? Yeah, what's going on?
Planning it out is like such a great way of like knocking it out because it makes it so much more simpler. So yeah, definitely like taking the time to like plan out the steps and stuff like really made this problem like super easy.
Awesome. Yeah. Right. I mean, there's so much that we're taking from yesterday too. Right. If we think about it, yesterday we had this, I accidentally commented it out, but right, we had pretty much the same counter helper. We just added a couple of things because we wanted to void characters and whatnot. Otherwise, we have the same like variable. We're iterating through it. And then we're just doing a slightly different logic, right? Here we're checking to see if we've seen an odd. While here we are just updating a length and updating another variable if we have an odd. And that's it, right? It's almost identical, almost. It's still tricky though, because like it's tough to recognize those sometimes. Can anybody think of another way we could go about solving this? Oops, sorry. Because let's see if we can identify multiple approaches. What's another way we could think about this problem? Okay, I'll give you a hint. I think, let me see, did we do it before? Yes. Okay, the hint is we did it before in a problem where we cared about pairs, specifically sock pairs. How did we solve that?
Corey, did we keep track of the middle with the sock pairs?
So let's go revisit our sock pairs.
We did like for it. I'm looking at it now.
Pretty sure we did something here, right? Here we did something. So in our sock pairs, the second time we solved it, we created this set where we were counting pairs. Should be fairly familiar because this is the same thing, right? This is counting pairs of characters before we were counting pairs of socks.
Oh,
For each sock or for each character, we check to see if our set has that sock. If it does, we can go ahead and increment that. Well, by this time, last time it was one pair. This time we would probably increment by a different number because we're not looking at pairs per se, we're looking at length of pairs. And then they went ahead and deleted the sock after we'd already seen the sock. Otherwise, we went ahead and added the sock before we just returned pairs. So how could we use that kind of idea for something like—
What are you doing?
I'm just trying to teach.
I'm sorry.
No, I'm just joking. Don't be sorry. That's the highlight. It's the highlight of my morning.
well, the pairs would be the letters, the evens, right? That we're looking for, and that sock, right? That sock that's like left over is that one odd that we want to add at the end. Since we're like ignoring the other one, so relatively, it's like the same way we solved that sock problem. We can definitely use the set to do this.
Okay. Yeah, I think I'm totally on board with that. Let's try to— I'm reading the chat and cracking up. Let's try to work on this. So we have our set. So we'll say we'll call it sets equal new set. Okay, so we've got this new set. We can iterate through this string. So we'll say for let character of string, because we don't care about the indices. We also need our length variable, right? Because that's essentially the whole point, which will still initialize to 0. And what do we want to check for? What's the logic?
It's like if set has if character, or if set has character, or I'm trying to figure out how to write it out.
Okay, I like that. If set dot has character.
Then we want to add to our length. But we also want to, but instead of deleting that sock, we want, like, that's that odd sock, that's where I'm getting confused. Like, that sock that we would normally remove, we want to keep track of at least one of them, right? So,
well, let's think about it. So, okay, let's go back to this string, or this, whatever string it was, this string, right? So we've got this string. Oops. Okay, and we've got our set. So right now our set has A in it. So we're going to put A in. So if we haven't seen it, we put A in, right? So we can go ahead and do that right here. Set.add character. Okay. We're good with that so far, right? Or no?
Yeah.
Okay, so we've got our A. So we've go ahead and added our A. Now we're in B. We don't have a B, so we'll go ahead and add our B into the set. We've got a C. So we're going to go ahead and add our C. We haven't seen it. Now we have another C. So what do we know right now for fact? What do we know about this C at least?
that there's at least 2 of them, like there's an even number of like C's, right?
So, yeah, exactly. I love the way you said that, right? There's an even number of C's. So if there's an even number of C's, what does our length do first off? Because our length was 0. What should our length become?
It should become 2 so far.
Okay, so our length goes up by 2. And should we do anything with this C?
Delete it.
Yeah, get out of the set, right?
How come?
Because we've seen it already. Well, it's a pair. Hold on. Well, we
Doug,
do. Yeah.
Go ahead, Marvin. You can keep going. Sorry.
If we see it again, because if we keep track of like another C, it becomes like an odd number, right? And we don't want We want to keep track of just like the evens right now.
Exactly, right? Because this current C is essentially closing this pair.
Yeah.
Okay, I'm on board with that. So we delete that C. So now we have another C. So that's not in our set, so we're going to add it.
Yeah.
And then we get a fourth C. So we should do the same thing. We'll increase our length by 2, which brings it to 4, and we delete our C. Now we have a D. So we have to add that to our set.
Right. And then same thing, because we're going to
Then
see.
we see that, yeah. So same thing, we'll make this 6. This will delete. So now our length is 6. This is what our set looks like. So let's just add that because we've already done some logic, right? Length plus equals 2.
Delete the
Set
character.
dot delete character. Oops. Okay. So at the end, though, we have to return something, right? But we know the answer is 7. So what can we do? How can we?
So if set, add 1.
If okay, so if set dot size.
Oh yeah, set that size. Then we want to add 1 to the length.
Okay, return length plus 1. Otherwise, just return length. I dig it, right? So, let's see if we can maybe do it like return length plus set dot size. Well, we'll keep it like this. This is really clear. Never mind. So set dot size greater than 0. Return length. I don't really need this else statement, right? I probably just write it like this. It's a little fun. So if we make it past that, we're just returning length. Okay, let's try this function and see if this one works. So we'll go over here, delete all of these. First, we'll just run the basic test. Okay, we got our 7. We try again with submitting all test cases, and we get it. And also, it looks to be quite a bit faster. I'm not really sure why. They're both. I guess we're only looping through the whole character one time instead of potentially more than once. What's the time complexity of these problems?
Linear.
Yeah, linear, right? Because we only iterate through. We have to iterate through every character of the string, but we're not doing like loops within those loops, right? We're doing it for this one. We're doing it once here, and then here we're just iterating through those keys, which is string dependent. Here we're just iterating through it once. A reminder that objects and set lookups, deletions, right? Those are all constant operations. That's what makes those such powerful data structures to utilize. What's our space complexity?
Linear.
Yep. So there could definitely be an argument made to be linear, right? Because for every character or additional length to our string input, we might have to store that much more space, right? If these were all unique characters, like I know you might be thinking, well, we're actively shrinking the set at the same time, but there's no guarantee that that string has any duplicates, right? Could somebody make an argument that this is constant space or this is constant space?
C.
What?
Yeah, you can.
Yes, you can.
Why?
Doing like a
It's
lookup, right?
going off of like one set of alphabet, like the 26 characters. Like But you,
Right.
well, since it's I'm sorry, since it's since it's case sensitive, then maybe 26 times 2, but that's it.
Yeah. So you're saying in this scenario, since we're only taking in strings that are uppercase and lowercase, we'll at most have to store 52 items, and that's it. So that's a constant amount of items, no matter what the input. And that's totally fair. So there's a case to be made for both of those. It's definitely a good idea to touch on both of those things. In this scenario, yeah, I would personally argue that this is constant space, because there is a specific number of characters that is allowed to come in through the input. But it is still n time. Great. So both of these solutions work. Both are good solutions. Right. This is just like the sock problem that we did a few weeks ago, and this is just like the problem we did yesterday. So just try to keep seeing those patterns and recognizing them, because it really makes it a lot easier to look at it as a pattern instead of an individual problem. Any questions on either of these? All right. Then I will stop recording.